Okay, فهلا it's chapter 4, huh? So we have 23 questions. This is very easy, like I told you, we're gonna go really quickly. Okay. Over here, again, it's so easy. In each of the diagrams, they're telling you which one is the least work and the greatest amount of work. أكيد the least work is when the angle is how much? 90. And the greatest work is when the angle is 0. Because work is equal to FD cosine theta. And cosine 90 is 0. So over here, the one with the least work would be figure E, with the greatest would be A. Question 2. A car is traveling along a straight horizontal road. Which forces have a negative work? Negative work, yani it slows it down. Would the weight of the car slow it down if it's on a horizontal road? Obviously not. Normal reaction, again, since it's horizontal, ما دخل. The tractive force of the car's engine. If you don't know what this is, tractive force is basically the force that the engine produces to move the car forward. Obviously that doesn't do a negative work, that does a positive work because it's moving it forward. And akid friction and resistance have negative works. Over here it's a man with a rope, the angle is 18, so theta is 18. The tension is 18, so the force is 18 newtons. The distance is 7.2. Akid find the work, so easy. The rule is FD cosine theta, so it's gonna be 18 times 7.2 times cosine 18. Akid in degrees, not radians, and you should get 123. So here my calculators in radians. Because I think so I don't need to do it. Right, easy. Alright, over here, when an object of mass 0.5 kilograms falls from a height of 17.8, the work done by gravity is 33.108. On which planet did the incident take place? What is the work done by gravity? The work done by gravity is mgh. Simply, 33.108 is equal to the mass, 0.5, times g, which we don't know. These are basically, we're trying to find the g, and we're going to match that g with the g in the table and choose which planet it is, okay? 0.5 times g times the height, 17.8. You should get that g is equal to, let's check. No, 3.72. So obviously you can see which planet is that. 3.72, Mars, right here. Okay, easy. Q5, a car of mass 1200 accelerates from 12 to a speed v over a distance 60. The net force acting on the car is 1500 newtons. Well, how much is v? Anytime you see a force, a distance, that means you can find the work. So the whole trick here is when you see the force in the distance, you see work. And since there's a change in the speed from 12 to a speed v, that means there's a change in kinetic energy. Simply, the rule is the work done is equal to the change in kinetic energy. So I don't like really using this. I like using this, that ME1 plus work external gets you the new mechanical energy. This is what I like using. Now ME1, at the start, it's kinetic energy 1, and that's at 12 meters per second. So it's half times 1200 times 12 squared, because that's the initial kinetic energy, huh? Plus work external is the force times distance, so 1500 times 60 equals the second mechanical energy, which is the second kinetic energy, which is half m v squared. Solving for v, you're gonna get 17. Let me do it. You get 17. Great. Question 6. A skier accelerates down a frictionless slope. What are the forces that cause an increase in her kinetic energy? Obviously, if it's a frictionless slope, someone's falling down. There's no friction slowing it down. What would cause her to speed up? What's pulling you down? Isn't it the weight? It is. Alright, so that's the weight that pulled her down. Alright. Question 7. A block slides down an inclined plane. Which is true about the work done by gravity and the work done by the normal force? Alright. The work done by the normal force is always 0. Why is this? Because the normal force is always perpendicular, right? So the work done by the normal force is always 0 because for a normal force, theta is equal to 90 degrees. Okay? Now how about the work done by the gravity? If you're sliding down, in what direction does the gravity pull you? It pulls you down. If your direction of motion is also down, that means the work done by gravity is in the same direction as the direction of the motion, and therefore that means it's a positive work, so it's greater than 0. Alright, over here a block rests on a rough, flat platform that moves horizontally. Which of the following is true about the work of static friction between the platform and the block? Obviously, the work done by friction is negative. Now, if it's not moving, then obviously the work done is 0. But here they're saying what's the work done by static friction? Obviously it's gonna be negative when it speeds up. If they said equals 0, that's only when it's at rest or when it's not moving. Okay? So over here, negative when the platform speeds up. Q9. A block slides upward along a rough inclined plane. What's the work done by gravity and work done by friction? Let's take a look. أول شيء, work done by friction is always negative. So obviously it can't be this one. And it can't be this one. And it's never 0. Why would it be 0? Alright, because it's a rough inclined plane. Anyway, so it can either be this one or this one. So we need to know, is the work done by gravity positive or is the work done by gravity negative? Over here, we're sliding upward. Right, we're sliding upward. If you're sliding upward, where does gravity pull you? Gravity pulls you down. If you're going upward, that means you're opposing the gravity, and that means the work done is negative. So that's why it's this answer. So always remember, if you're going up, then work done by gravity is negative. If you're going down, then work done by gravity is positive, okay? Q10. A parcel with mass of 5 kilograms is being lifted vertically upward through a height of 3 meters. What is the absolute value of the work done by gravity during this motion? Simply, I'm not going to calculate this, it's mgh. So easy. A box is pulled across a horizontal floor with 45 newtons while experiencing 11 newtons in the other direction. The total work is 1200 joules. What is the distance through which it was moved? So easy. If the force is 45 newtons, to the left, it's 11 newtons. The total work is 1200. Isn't work equal to force times distance? Yes. So 1200 is equal to the force times the distance. Which force do we take? We find the net force. If you have 11, this is an 11, sorry. If you have 11 going to the left or 45 to the right, how do you find the net force? You simply subtract them. You get 34 newtons. So you're going to get over here 1200 is equal to 34 times the distance d, we don't know it. And then you do 1200 divided by 34. Alright, this looks intimidating, but it's actually very easy. So they gave you the force, but in vector form, and they gave you the distance or displacement, also in vector form. What is the work done by this force? Alright, simply we know that work is equal to force times distance, k times cosine theta. So when you have vectors, it's simply the dot product between the force and the displacement. How do you calculate dot product? It's this one times this one plus this one times this one, right? So let's do it. So negative 1 times 2 is negative 2 plus the 2 times negative 5, which is negative 10. So you negative 12 joules. So easy. A force F 3I plus 4J acts on an object that undergoes a displacement of 3 meters. The work done by the force is 6 joules. What's the angle between the force and the direction of the displacement? Simply, we know that work is equal to F d cosine theta. Right? So force, we don't take the vector form. We want to take its magnitude if you want to put it here. What's the magnitude of 3i plus 4j? It's radical 3 squared plus 4 squared, which is 5. So over here for the force, we're going to put 5. The displacement we know is 3. Cosine theta, we don't know it. Equals 6. So we got 15 cosine theta equals 6. So cosine theta is 6 divided by 15, which is aslan 2 over 3, not 2 over 5. So we do shift cosine, and you get 66.4 degrees. Very easy. Over here, which ones are false? Akid. Let's see. When the force is orthogonal to displacement, it does zero work. We know this is true. Orthogonal means perpendicular. So when the force is perpendicular to displacement, obviously the work is zero. The obtuse angle between the force and displacement results in negative work minus force. What does this mean? Obtuse angle, yani the angle, is greater than 90. Isn't work equal to FD cosine theta? Yes. Cosine theta becomes negative if your angle theta is bigger than 90. Okay, that's the rule for cosine. If the angle is bigger than 90, then cosine theta becomes negative. So that's why this one here is true. So you select it. The obtuse angle between the force and displacement results in negative work. The maximum work is attained when directions of force and displacement coincide. That's true. What does maximum work mean? Yani you get the highest work. شو يعني coincide? يعني the force is to the right with the displacement كمان it's to the right. See how they're in the same direction? طيب. When a force is parallel to displacement, it does zero work. If they're parallel, why would it do zero work? It only does zero work if and only if it's perpendicular. Okay? With the last one over here, a car moving uniformly has zero work done on it. If it's moving uniformly, that means the net force is zero. If the net force is zero, yani W is equal to 0 times D, which is 0. Alright, over here, they told you, a block slides a distance D across a rough surface before coming to rest due to friction. So the friction stopped it. Okay. If the initial speed of the block is doubled, how does the distance change? Now, here we're talking about kinetic energy. When we talk about distance and kinetic energy, remember that kinetic energy is half mv squared. So when you're doubling it, if you're doubling the speed, that means you're doing times 2 squared, which is actually times 4. Okay, so the distance becomes 40. Let's continue to question 17. A trolley of mass 11 is moved across a frictionless horizontal floor by a force with horizontal component of 5 newtons. If the trolley starts from rest, what distance will it travel before reaching a speed of 2 meters per second? So easy. Again, they gave you mass, so they're giving you speeds, or they're giving you force, or they want distance, and in the formula you can use is simply the work energy theorem, that work is equal to the change in kinetic energy, or the way I do it, ME1 plus work external equals ME2, which is the same thing, by the way. Anyway, the first one we solved it with ME1, let's try this one with delta K. Okay, work done is force times distance. Delta K is K final minus K initial, yani half MV final squared minus half MV initial squared. But so on, they said it was starting from rest, initial is 0. Okay, force times distance, so 5, these distance equals half MV squared, so half, the mass is 11, with the final velocity squared is 2 squared. So you get D is equal to 22, you get 4.4 meters. Alright, over here, a 5 kilogram load is sliding down a frictionless surface. If originally the box was at rest, what is its speed at the bottom of the slide? This is so easy. Bas yalla. You're 1.5 meters high. Or do you want to find the speed when you're down here, okay? It's so easy. Simply, like I told you, ME1 equals ME2. This is why I like using this formula, not work equals delta K, because this one's applied in every case. Okay? There's no forces being applied here, so we're just going to say ME1 equal ME2. Initially, since you're at a certain height, your mechanical energy is composed of the potential energy, gravitational potential energy, and kinetic energy 1. and me2 will be the second potential energy, u graph 2 plus kinetic energy 2. Now, this is the way I solve, and then I start cancelling things out. Obviously, if you're starting from the top, you're not starting with any velocity, so k1 is 0. Obviously, since you're falling to the bottom, your height will then become 0. That means u gravitational is 0 since the height is 0. If you don't know what u gravitational is and you're in 12S, that's a big problem. What's potential energy, gravitation, potential energy, mgh? That's a very big problem, okay? Anyway, so u gravitation is mgh, so at the start we can just simply say mgh is equal to half mv squared. You can cancel the m with m, it doesn't really matter. Okay, g is, let's take it as 10, height is 1.5 equals half v squared. You can multiply, you'll get v squared equals 30, so v is radical 30, which is 5.4. Over here, it's a car with mass 900 accelerating from rest to a speed of 15 over a distance of 100 while experiencing a force, blah 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 blah. Wallah ta'bid, bruh. What is the magnitude of the force exerted by the car's engine during this acceleration? Okay, this is so easy. Basically, again, you have a mass that's changing speed. They gave you distance or they want force. So again, we can simply use me1 plus work external equals me2, or you can do work is equal to delta k, whatever you want. me1, initially we're starting from rest, so it's 0. Okay, well, there's no sliding, no height change, nothing. Okay, so it's just 0. Work external is force times distance, yeah, equals me2, which is half mv2 squared. Now the force, we don't know it. Now someone might tell you, oh, isn't the force 700? La, it's the friction force. Okay, the net force F, will be the F by the engine minus the friction force, F of friction, right? So in other words, it's going to be F of engine minus 700. So over here, the force here, we're just going to call it F of engine minus 700 times the distance, which is 100 meters, equals half mv squared. So half 900 with the velocity squared, so 15 squared. You can solve this very, very easily. So you're gonna get 15 squared times 900 divided by 2 divided by 100 plus 700, and you get 1712.5, which is, to scientific notation, 1.7 times 10 to the power of 3 newtons. Over here, a 200-gram ball is dropped from rest at a height of 1.8. It rebounds to a height of 1.2 meters after hitting the ground. What is the speed of the ball just before it hits the ground? Okay, yeah, I got cut off. If you're watching the mechanics video, there's the 4 people who joined my call and started moaning. Anyways, whoever that is, shout out to you guys. I guess you know yourselves. Thank you for ruining my calls every single time. I appreciate it. So I don't really care. It's like you guys are kind of repeating the joke every single time now. It's not really getting. It's getting unfunny. Anyways, as I was saying, a 200-gram rubber ball is dropped from rest from a height of 1.8. It rebounds to a height of 1.2. What is the speed of the ball just before it hits the ground? Yeah. Anyway, this is very easy. This 1.2 is kind of like I don't know why they put it. But in general, they gave you 1.8 meters with 200-gram rubber ball. What's the speed of a ball just before it hits the ground? Now, again, if you're starting from the top, you're going to the bottom. You have potential energy. Then at the bottom, what's the speed? It got converted into kinetic energy. So this potential energy, or U grav, got converted into kinetic energy. So we're going to do me1 equal me2. There's no external forces, so we're not going to say work external. So at the start, we don't have any kinetic energy, so I'm just going to put U gravitational. At the end, we don't have any gravitational energy, so I'm just going to put kinetic energy. Alright, fine. Now, U gravitational is mgh. Kinetic energy final is half mv squared. We can cancel m with m. You're going to get that v is equal to, multiply the 2 on the other side, is going to become 2gh, and then square root, you get square root 2gh. So 2 times 10 times 1.8, and you get 6. Alright? Alright, great. So 21 now. 2 identical blocks of mass m are connected as shown below. The coefficient of kinetic friction between the inclined surface and the mass is 0.2. The system is released from rest and the block moves a distance of 1.5 meters. What's the speed of the blocks after they have moved to this distance? So this is a typical chapter 3 question. I don't know how other people solved it. but I'm just gonna do me1 equals me2. It's very easy. So what's happening here? They're asking us what's the speed. They told us that the system is released from rest and the blocks move distance 1.5. Okay, this block is gonna move down, وهيدي هون it's gonna move up like this. Okay, it has some kinetic friction. So for this one the solution is way too long, so I'm just gonna skip it. So it didn't come in the periodic, so I don't think it's gonna come next time. Q22, a force given by for F is this, is used to move an object 3 meters away from the origin. What's the work done? The work done is integral F dx. Very easy. Okay, so you go here, integral 2 over x plus 1 squared. They're moving it from 0 meters to 3 meters. So you do this to this, you get 1.5. So easy. Last question, 23. A massless spring is compressed by 0.2 meters by force 20 newtons, 0.3 meters by force 30 newtons. What's the constant, the spring constant? F is equal to kx. So simply 20 divided by 0.2 and you get 100. Okay? The work needed to compress the spring by 0.2. The work for a spring is half kx squared. Okay? So since you know that the k is 100, so you do half times 100 times x squared, so 0.2 squared, and you should get 2. And for 0.3 meters you do the same thing, but instead of 0.2 you do 0.3 and you should get 4.5. هيك نكون خلصنا. Very easy, 4.2. Thank you for watching. Good luck in your exam.